This question is from last year Iiser Aptitude test. Let us solve this question. Let alpha be a real number. What is the total number of distinct points of intersection between the parabola and the pair of lines? We have equation of one parabola and equation of a pair of line. We need to find how many points of intersection. What are the number of distinct points of intersection? They haven't asked the solution. We need to find how many points of intersection only. We don't need to find which all are the points. Now what I am doing, first I am taking this pair of equation of lines. If you want, you can directly write y equal to 1 or y equal to minus 1. You can take the square root, or you can take this 1 to the side. Y square minus 1 equal to 0, y minus 1 into y plus 1 equal to 0, which means y minus 1 equal to 0 means y equal to 1, and y plus 1 equal to 0 means y equal to minus 1. Both will get us the same result. Now I am taking the equation of this parabola. The equation of parabola is given as y equal to x square plus, what I am doing, I am taking these two terms together. For sine alpha x, for sine alpha into x plus 6. Whenever you get these kinds of equation, the easiest method, if the quotient of x square is 1, we can complete the square easily. If the quotient of x square is not 1, make it as 1. You can take the value common. If the quotient of x square is 1, take the half of the quotient of x term. Half of the quotient of x term is half of this term is 4 sine alpha. Half of 4 sine alpha is 2 sine alpha. Take the square of 2 sine alpha, add and subtract 2 sine alpha square respectively. Now what I am doing, I am taking these two values to this side, this value and this side. When I take this value, y minus 6 plus 2 sine square alpha, 2 sine alpha the whole square, 2 sine alpha the whole square is equal to x square plus, I can write it as 2 into 2 sine alpha into x plus 2 sine alpha the whole square. These two value I have taken to this other side, and the remaining 1, 2, 3 values I have written. Now I can write it as y minus of 6 minus 2 sine square, 2 sine alpha the whole square is 4 sine square alpha is equal to, this can be written as x plus 2 sine alpha the whole square, a square plus 2ab plus b square 4. Now I can draw the equation of parabola. I can draw the graph of parabola. We have the straight lines as y equal to 1, y equal to minus 1 respectively. Now what I am doing, I am drawing an xy coordinate. Y equal to 1 represents this line which is passing through y equal to 1, and the another one is y equal to minus 1 which is passing through minus 1. Now we can consider this parabola. We need to draw this parabola. Have you seen the quotient of x square? Is the quotient of x square is positive or negative? Whenever you get a parabola, equation of parabola, if the quotient of x square is positive means it will be a parabola moving upward. This is the shape. If the quotient of x square is negative, we can write it, draw the parabola as like this, which means here the quotient of x square is positive plus 1, which means our parabola will be vertically, it is moving upward, which means its axis will be along the positive y axis. It's similar to the parabola with the positive y axis. Now when you consider this one, what is the general form of a parabola? Y minus k the whole square is equal to x minus h the whole square, 4a into 4a into x minus h the whole square, which means if you subtract some quantity with the y, its origin is shifted, which means the vertex is at no point at k. This is the equation of parabola with the vertex at h comma k. Similarly, if you consider this one, its vertex of y axis, the y coordinate of the vertex is at which point? 6 minus 4 sine square alpha. The maximum value of sine square alpha is 1, which means the least value of k, that is the y coordinate of the vertex, the least value is 6 minus 4 when sine theta is maximum, which means sine square alpha is either maximum plus 1 or minus 1, which means sine square alpha is maximum. Now the minimum value of k, that is the vertex of the y coordinate of its vertex is 2, which means the parabola will be somewhat like this, which means the parabola won't touch any of the line, which means the point of intersection of the two curves are 0. Hence, we don't have any common intersection point, which means the intersection point, the number of distinct point of intersection is 0. There is no intersection point.